Okay, guys, hello and welcome to this second Cloud with Day. Uh, Welcome again to this designing and implementing Microsoft Azure AI solution. Today, we are going to cover three more modules, starting by building speech-enabled applications. The next one will be the creating language understanding solutions, and last but not least, building a questions answering solutions. Also, after this session, this theoretical session, we need to cover another six laboratories. So don't worry, we have plenty of time today to finish this and cover these modules. Okay, guys, and welcome again. I hope you're doing great. So let's start with this building speech-enabled applications. Our agenda for this module it is speech recognitions and synthesis and speech translation. Okay, guys? So let's start with speech recognition and synthesis. But first of all, we need to talk about the speech service. This speaker recognition API, it is actually in preview. So don't worry if we don't talk about this in this module. We are focused on the speech to text and the text to speech. We'll cover speech translation in the next lesson. Don't worry. So the speech services provides an APIs for developing speech-enabled apps. The speech service specifically supports this list: speech to text. This is an API that enables speech recognition in which your application can accept spoken input. We have, we have the text to speech. This is an API that enables speech synthesis in which your application can provide spoken output. Remember, the first one can accept spoken input, and this one can provide a spoken output. So we have also the speech translation. This is an API that we can use to translate spoken input into multiple languages. And the next one, we have the speaker recognition. This is an API that enables us to, enable our application to recognize individual speakers based on their voice. So, and after that, we have this intent recognition. This is an API that integrates with the language understanding service. We are going to see this service in the next module, don't worry, but this determines the semantic meaning of spoken input. Okay, this service can be used as a standalone speech resource like the cognitive services or a multi-service cognitive services resource. Okay, so let's talk about the first of these services, the speech to text. There are two REST APIs, one specifically for short bursts of speech, and the other for batch and custom speech recognition. In most cases, you'll likely use one of the SDKs which offer consistent programming pattern for working with speech. Depending on the length of the spoken input, you can use either API for interactive speech recognition, or you can also utilize the speech to text API for batch transcription, which converts many audio files to text at once. Okay, so in order to make this, we have this little diagram, and this is the whole process in using net core, Python, JavaScript, and so on. First of all, we need to encapsulate the information needed to connect to your speech resource. Use a speech config object. Let me, okay. Your speech config object. In particular, its location and key, okay? Then we need to use audio config to define the source of the audio to be transcribed. if you want to, this is a system microphone by default, but you can also choose an audio file we have right here. Okay? Now, to make speech recognizer object, this one, we use the speech config and audio config. This thing is a client proxy for the speech to text API. Okay? Then we need to use the speech recognizer objects methods to call the API functions that make it work. For example, the speech service is used by the recognize once async method to transcribe the async spoken utterance in a synchronous way. And at least, well, last, handle the speech services response for the recognize once async method. The result is an object like duration, often offset index, properties, reason, result ID, or text. So if the operation was successful, the reason property, this one, reason property will have the enumerated value recognized the speech and the text property will have the transcription. Other values for the results are no match, which means the audio was successfully parsed but no speech was found. Or you can get cancelled. This means an error happens, in which case you can maybe check the properties collection for the cancellation reason property to determine what went wrong. Okay? So, like speech to text APIs, the speech service has two, uh, two APIs for making speech. So, the main way to do speech synthesis is through the text to speech API. Now, we have the text to speech long audio API. This is made to support batch operation that convert large amounts of text to audio. For example, you could use it to turn the source text into audio block. Like the speech to text, we need to use speech config object to hold information you need to connect to your speech resource, specifically what it is and how to get to it. Okay. Then you can use audio config to set the output device sorry, to output device for the speech that will be synthesized, but it is not required. By default, this is the default system speaker. But you can also specify an audio file, or you can process the audio stream object that is returned directly by setting this value to null. Okay? Now, you can make a speech synthesizer object by using the speech config and the audio config. This object is the text-to-speech API client proxy. So then we need to use the speech synthesizer objects methods for call the API functions that make it work. For example, the speech service is used by the speak text async method to turn text into spoken audio. We have right here. And, and last, we need to handle the speech services response for the speech text async. The result is an object called speech synthesis result that has the following properties: audio data, properties, reason, and result ID. So when speech has been synthesized successfully, the reason property is set to audio completed, right here. And, and the audio, well, property contains the audio stream. Okay, so don't worry if I'm talking about a lot of methods and so on. We are going to see this in the laboratories, okay? So don't worry about that. Okay. Now, Let's talk about the audio formats and the voices. Using speech config object, you can change the sound that the speech services sends back when you are synthesizing speech. Talk about the audio format. The speech synthesis creates an audio stream which can be sent to the speech services in a number of different formats. You can choose a format based on the required audio file type, sample rate, or bit depth. Now, the speech synthesis output format enumeration in the SDK shows which formats are supported. One example is this one, speech config dot set speech synthesis output format, and we define the speech synthesis output format to this value, rev 24 kilohertz, 16-bit mono PCM. Okay, now we use this um, set speech synthesis output formats to tell it what output format to use. Okay, it is just for that. Now, the speech service gives you a variety of voices. You can use to customize speech-enabled apps, and you can use two different kinds of voice. We have the standard voice. This is our voices made out of sound samples, or we can use neural voices. These are voices that sound more natural because deep neural networks were used to make them. Now, the voices have names that include a location and a person's name, like this one, okay? And GB George, okay? Okay. Now, we need to, in this case, set the speech synthesis voice name uh, to the name of the voice you want to use into to the speech synthesis. Okay, we have a lot of voices. Let me show you. Well, let me send you the documentation. Give me a sec. Give me a sec. I have right here the list. Uh, I think it is right here. Okay, it is right here. And we have the voices, and if we can use the neural voice or not. Okay, let me send this to my partner right here, and he will post it in the Q&A section. Okay, let's continue. Now, you can use the speed text async method, for example, to turn plain text into speech using the speech SDK. Now, the service also supports an XML-based syntax for describing the features of the speech you want to make. This syntax for speech synthesis markup language, or SSML, gives you more control over how the spoken output sounds. This lets you specify a speaking style, such as excited or cheerful, when using a neural voice. Okay? We can insert pauses or silence. We can specify phonemes, these phonetic pronunciations, for example, how to pronounce, for example, the text SQL to SQL, okay? We can adjust the prosody of the voice. This affect the pitch, the timbre, and speaking rate. And sorry, we can use common say as rules, for example, to specify that given a string should be expressed as a date or as a time, a telephone number, or another form. And we can use the insert or record in the speech or audio, for example, to include a standard recorded message or simulate background noises. Okay. For example, consider this SML in the slide. This specifies a spoken dialogue between two different neural voices like this. Let me, okay. We have, in this case, Aria. Well, in this case, it's Ariana, if I am not wrong, it is Ariana. And in a style cheerful, she says, I say tomato. And this guy neural, we can use the phonetic pronunciation in order to pronounce, I say tomato, okay? And we can add a pause, a break week, and and so on, okay? So this guy, it says something like, I say tomato, let's call the thing off, okay? So to submit this description in to the speech service, we can use a method called speak SSML async. Let me, it is right here. Sorry, it is right here. And you just need uh, to pass to parse the SML string. In this case, just need to add something else right here. Give me a sec. I will, sorry, my ugly letter. It is something like speech, uh, sim, sorry, empty sizer dot. This is the, remember, this is the object and this is the method. Okay? Now, let's talk about the speech translation. Remember, if you have any question, feel free to ask in the Q&A window, and my partner will answer everything. Okay. So let's continue to speech translation. Give me a sec. I will drink a little, drink some water. Okay. Thank you. Okay. Now let's talk about the translation, speech to text. Now, translation speech builds on speech recognition by recognizing and transcribing spoken input in a certain language and returning translations of the transcription in one or more other languages. Now, speech translation with the speech SDK works in a similar way to speech recognition, but it also needs information about the source language and the language to which it will be translated. Once again, we have this little diagram, and first of all, we need to use the speech config object to hold information you need to connect to your speech resource, specifically the location and the key. Okay. Then we need the speech translation config object, sorry, to set the speech recognition language and the target languages in which it should be translated. Then we need to use the audio config to define the source of the audio to be transcribed. If you want to, this is a well, this is a system microphone by default, but you can also choose an audio file. Now, to make the translation recognizer object, you need to use the speech config, the speech translation config, and the audio config. This object is a client proxy for the speech service API for translation. Now, after that, we use the translation recognizers object methods to call the API function to make it work. For example, the speech service is used by the recognize once async method to translate a single spoke utterance in a synchronous way. Then we just need to handle speech services response for this recognize it once async method. The result is an object called speech recognition result. And like the first one, we have the following properties: duration, offsetting text, properties, reason, result ID, text, and translation. Now, if the operation was successful, the enumerated value is in reason property. Again, once again, recognizing the speech, the text property has the transcription in the original language, and then translations property has dictionary of the translation. This is using the two characters ISO language code, such as EN for English as a key. Okay, now the translation recognizer takes spoken input and translate it into text. You can also make a speech-to-speech translation solution by putting the translation back together as a speech. You can do this in two different ways. We have the event-based synthesis and we have the manual synthesis. Okay? Okay. Now, when you want to do one-to-one translation from one source language to another target language, you can record the translation as an audio stream using the event synthesis. In order to do this, you must uh, in the translation config, we need to choose the voice you want to translate speech, then make the event handler for the synthesis in event of the translation recognized object, and then use the get audio method of the result parameter in the event handler to get the byte stream of the translated sound. Depending on the programming language you are using, the code you use to set up the an event handler will be different. Let me show you in the documentation. Let me end the slide is real quick and let me show you. Just give me a sec right here, guys, and I will show you real quick. Okay, right here. Once again, I will send this to my partner right here in order to to send it to the whole audience. Okay, guys. Okay, we have right here the programming language. We have C Sharp, C++, Go, Java, JavaScript, Objective C, Python, Swift, CLI, or REST. Okay, you can check right here how to make it. For example, with C Sharp, we have the sample codes. Okay, so this will help you guys to start working with the speech services. Okay, let's continue and let's take our review. Okay, so let's take this review. The first one says, which object should you use to specify that the speech input to be transcribed to text is an audio file? I'll give you a couple of seconds, guys, and then I will show you the answer. Okay? Remember, we need to use audio config to specify the input source for speech. Now, how can you change the voice used in speech synthesis? Okay, I'll give give you a couple of seconds, guys. And let's see. Remember, to set a voice, we need to set the speech synthesis voice name property of the speech config to a voice name, such as the ngv George. Okay, remember that. Now, last one. When translating speech, in which cases can you use the synthesizing event to synthesis the translation and speech? We already saw this in the last slide. Give you a couple of seconds, guys. Okay. Okay, you can remember you can only use event-based synthesis when translating to a single target language. Okay, guys, let's continue with the next module, and after the module, we're going to take a break. Okay, let's see the next module. In a sec, I will open the next module real quick. Okay. Now, let's talk about creating language understanding solutions. Our agenda will be the first of all it is creating a language understanding app, and then how to publishing and using this language understanding app. Okay, so let's start. Natural language processing, or also known as NLP, is a common AI problem in which software must be able to work with text or speech in the same way that a human user would write or speak. Now, natural language understanding is a part of the NLP that tries to figure out the semantic meaning of a natural language. This is usually done by using a trained language model, a common design pattern for a solution that helps us to understand a language solution like this. Okay? Okay? And we have first of all, the app accepts the natural language input from a user. Then the a language model is used to determine the semantic meaning or the user intention, and the app performs an appropriate action. The language understanding service in Azure lets uh, lets all clients, users, or us as developers to make apps based on language models that can be trained with a small number of samples to figure out what a user meant to say. Now, to build an NLP solution with the language understanding service, we'll need to set up a language resource in Azure. That resource will be used both to write your model and to handle requests from client applications to make these predictions. The language service has many features, such as sentiment analysis, the key phrase extraction, the entity recognition, the intent recognition, and text classification. Some of these features, like the language detection and the sentiment analysis, can be used even if your language resource is not set up, and other features like understanding conversational language and recognized custom name entities will need a model to be built so that they can be predicted. Okay, let me show you how to create this in the portal. It is pretty easy, guys. So don't worry about this to create these services. It's pretty easy to do that. Okay. First of all, just need to go to the portal azure.com, then click on create resource. Right here, you just need to look for language. Press enter, and here we have language service. We have the language service, then just click on create, and we have the custom features, the custom question and answering, and the custom text classification and custom named entity recognition. Okay. In this case, I'm going to select both of them because we are going to use this in the next module. So let's click on continue to create your resource. Once again, we need to select our resource group, our region. My recommendation again, it is East US, and the name. And this can be language cloud week Leo. Let's see. Hey, my pricing tier. In my case, I just need the free one. And okay, custom question or an answer. Okay, we can leave this as default. And for this case, the custom text classification and custom name entity, we need to create an storage account or select an existing one. I have one, but I don't want to use this one, so I'm going to create a new one. My storage account name will be storage account which Leo. My tag standard locally redundant storage, and I'm going to check this and then click on review and create. Let's wait to the validation. Click on create, and that's all, guys. Just need to wait to resource to be deployed. But in the meantime, we can continue, okay? And after that, we are going to back to this resource. Let me go back to the slides. Okay, now let's continue to talk about the intents and utterances. Well, now the utterances are words or phrases a user might type into an app that uses your language understanding module. And the intent is a task or an action that the user wants to do, or the meaning of the word or phrase. In this case, uh, the intent is the meaning or the meaning of the utterance or the intention of the users. Okay, we need to make our module by defining intents and linking them to one or more utterances. Consider this list we have right here in the slide. For example, the intent, get time, we have what time is it, and tell me the time. We can also say what is the time. Okay, we have the get weather, and the weather is what is the weather forecast? Do I need an umbrella? Will it snow? Will it rain? Etc. And we have the turn on device. For example, we have the turn the light on, switch on the fan, or switch on the light. And we can define intent as none. For example, hello, goodbye, and so on. Now, in a language understanding model, you must define the intents you want the model to understand. So we need to take some time to think about the main your model must support and the kinds of actions or information users might ask for. In addition to the intents you define, every module has a non-intent that you should use to clearly identify utterances that user might submit bots for which there is not specific action required. For example, greetings like this hello or goodbye. Then, after you figure out that what intents your model needs to support, it is important to record different examples of what each intent means. Rather, utterances you think users will use, including ones that mean the same thing but are put together in different ways. Sorry. So these guidelines take keep this in mind. We need to capture multiple different examples or alternative ways of saying the same thing. For example, what time is it? Tell me the time. Will it snow? Will it rain? We need to vary the length of the utterances from short to medium to long. We need to vary the location of the noun or subject of the utterance. Place it at the beginning, at the end, or somewhere in the between. A tip is use correct grammar and incorrect grammar in different utterances to offer good training data examples. This it is a good tip that. And the precision, consistency, and the completeness of your label data are key factors to determining model performance. Label, label precisely label each entity to its right type always. Only include what you want extracted. Avoid unnecessary data in your labels. Label consistently. The same entity should have the same label across all the utterances. And last, save label completely. Label all the instances of the entity in all your utterances. Don't worry about these labels right now because probably you don't know what I'm talking about. We are going to see this in the lab. Okay, my deployment is complete. Let's take a look. Right here is my language service, my cognitive search service, and my storage account. Let's take a look at my language cloud week. Okay, if you can see, I don't have much options right here, like my just my keys and endpoints, my features, and so on. So in order to make a project, we need to go to Language Studio right here in the overview, then click on the Language Studio. Sorry. And okay, I need to sign in again. Give me a sec. Okay. Yeah, my description. Okay, and here we can create anything. We can create, for example, in this case, the language understanding. For example, the name, language, language understanding test, description, test purposes, English, okay. Let's click on next, let's click on create, and that's all. We have our intents, for example, what time is it? Sorry, uh, get time. This is my intention, and we can add utterances. Okay. Example, what time is it? What is it the time? Will it rain? We just need to save the changes. That's all. Let's okay. We can test this. Okay. Example. Uh, what is the time? Let's save this. And well, after that we need to deploy this, but don't worry, just we need to deploy right here. But let's uh, let's continue, and after that we are going to deploy this module. Okay, but this is our training set, our testing set, and that's all. We need to save the changes in order to deploy our modules. Okay, let's continue. Now, the entities are used to give intense more details about what is going on. For example, you could define a turn on device intent that can be used on more than one device and then define the different devices using entities. Okay? It is possible divide entities into several distinct parts. The learned entities, these are the most useful and should be used most of the time. You give a learned piece of information, a name, and then use training utterances to link words or phrases to it. When you train your model, it learns how to match the right part of the utterance to the right entities. Now, the list entities are helpful when you need an entity that can take a certain set of values, like the days of the week, or you can include synonyms in the definition of a list entity. For example, you could define a day of week entity with the values Sunday, Monday, Tuesday, and so on. And each value could also be written as sun, month, and tune, like this. And let me write it in the right here. Give me a sec. Screen, right screen. For example, okay, we can write this list entities. Sorry, my ugly letter. Okay, Sunday, um, Monday, Tuesday, and so on. But we can set synonyms for this one, like sun, mon, and chu. And our project, our model, will interpret this synonym and match to the weekday. Okay. Then we have the pre-built entities. The pre-built entities are useful for common types like numbers, date times, and names. For instance, when pre-built components are added, you can automatically find values like 6 or companies like Microsoft. In some cases, a model might contain multiple intents for which utterances are likely to be similar. In this case, you can use the pattern of utterances to disambiguate the intents while minimizing the number of sample utterances. For example, consider the following utterances. Let me um, let me go back to the language studio. Where is it? Right here. Okay, I'm going to add another intent. For example, turn on device, get device status. and turn off the device. Okay. Let me end the slide real quick just to avoid to keep switching screens. Okay, great. For example, if I want to turn on a device, we can select this utterance. For example, turn on the kitchen light. But for example, is the kitchen light on? We want to get the device status. Okay, what happened? Is the kitchen light on? Okay, this. Give me a sec. I don't know what is happening. Device status. Okay, that's great. And for example, if we want to turn on a device, we can say turn off the kitchen light. Okay. These utterances are syntactically similar with only few differences in words or pronunciation. However, they represent three different intents. In this case, the turn on device, the get devices status, and turn off devices. Additionally, these intents could apply a wide range of entity values. In addition to kitchen light, the intent could apply to living room light, bedside lamp, fan, television, or another device that the module might need to support. Okay. For example, the entity will be in this case light. Well, in this case, I don't have entities. I need to add a new one. For example, let's see. Uh, mm, device. Let's see. Light. Let's add another one. Where is it? Learn. Okay. And for example, fan. Okay. And let's see, for example, turn on the device. Okay. Intent turn on the device. Right here. Let's add another one. Turn switch on the fan. So right here, this is my entity, and this is another one entity. This is in order to create advanced language understanding application like Alexa, or no, Siri, and so on. Okay. So once again, these are the entities, and we need to define a lot of intents for maybe the same or similar utterances. Okay. So let's continue. Okay. Yeah, let's continue. Now, you can make your own language module by defining all intents and utterances it needs. However, you can use pre-built components to find common entities like numbers, emails, URLs, or even choices. When you use these pre-built components, the language service can automatically find the type of entity you've asked it to find. You don't have to train your model with examples of that type entity. Okay. Now, creating a model of language understanding is an ongoing process that includes the following steps. Train the module to learn intents and entity from example sentences. You can set the model either by interacting with it or by using testing sets with known labels. Put a trainer model on public endpoints so that the client's apps can use it. And after that, we just need to review the prediction and repeat what was said to train your model. Okay? By using this iterative method, you can improve the language model over time based on what user says. This will help you come up with solutions that match how users says what they want to do in the natural language. Okay, let's continue. Let me drink some water. Thanks. Now, with a language understanding service, you can create and train language model that can figure out what a user wants based on what they say in natural language. To use this module in an application, you need to publish the language understanding app for your model and use it from a client application. So the language services, the language service, sorry, has different tools for understanding how people talk. A client application can use each feature to communicate with users better, or it can use them all together to learn more about what the user is saying, meaning, and asking. There are two types of language service features, those that are already set up and that are learned. For learned features, you need to build and train a module that can correctly predict labels. Certain features of the language service can be used without any model labeling or training. Once you made your results, you can send your data and use the results in your app. The following features are all pre-configured. Okay? Summarization. The summarization is available for both documents and conversation. It breaks the text down into key sentences and that are told to capture the meaning of the input. We have the named entity recognition. This named entity recognition can pull out and identify entities like people, places, or companies. This lets your app recognize different types of entities for better natural language responses. For example, if the text say something like, "My favorite thing about Seattle is the waterfront pier," Seattle will be named as labeled as a place. Now, personally identifiable information, or also called PII detection. This PII detection lets you find, sort, and remove information that could be considered sensitive, like email addresses, home addresses, IP addresses, names, or protect the health information. For example, if our query in the REST API includes the text email at uh, contoso.com, the whole email address can be found and hidden. We have the key phrase detection. The key phrase detection feature quickly pulls out the main ideas from the given text. For example, if you gave the service the text analytics is one of the features in Azure Cognitive Services. This key phrases detection, it will pull out Azure and text analytics. Then we have the sentiment analysis. This one tries to figure out if a string or a document is positive or negative. For instance, based on the text, um, excellent hotel. We could walk to a lot of places to eat and see. In this case, the service will say that was good, a fairly high level of confidence. Remember yesterday the Twitter example with the Formula One hashtag or the F1 hashtag. We get, if I'm not wrong, we get just one tweet, one negative tweet talking about the Max Verstappen and this the Mexican pilot Checo Perez. Okay. Then we have the language detection. Language detection looks at one or more documents to figure out what language each one is written in. For example, if one of the documents says bonjour in within the text, the service will know that it was written in French. These are the pre-configured features. Now we have the learn features. For learn features to work in your application, remember, we need to label data, train your model, and deploy it. With these features, you can change what information is predicted or extracted to fit your needs. We have the conversational language understanding. One of the most important custom features that Azure Cognitive Services for Language offers is the CLU, or Conversational Language Understanding. This CLU lets users build their own natural language understanding modules to figure out what people are trying to say and get important information for what they want to say. This CLU does need the user, or in this case the developer or us, to tag data in order for it. Okay. Then we have the custom named entity recognition. The custom entity name recognition uses data that has been labeled by the user to pull out certain entities from unstructured text. For example, if you have a bunch of contract documents and you want to figure out who is involved, you can teach a module how to do that. We have also the custom text classification. This custom text classification let us put text or documents into groups that they make themselves. For example, we can teach a module to look at new articles and figure out where they belong, such as in the news or sports or entertainment category. We have then the question answering. The question answering is a feature that, for the most part, is already set up and gives answer to questions that are given as input. Documents like frequently asked questions or manuals have the information needed to answer these questions. For example, say you want to make a virtual chat assistant on your company's website to answer common questions. To make the question and answering pairs, you could use a company's frequently asked questions as the input document. Once the service is set up, your chat assistant can send the question to it and get the answers. Let me send this documentation because this kind of huge documentation right here. Right here we have the named entity recognition. How can we use this? With the documentation REST API, the C#, JavaScript, Python, for example, REST API. We can see how can we send this request. We can use curl, we can use Postman, and so on. Okay, and we have the parameters, the request header, body, and so on. Let me send you in the chat or in the Q&A. Save. Let's continue. Okay. Okay. I just sent to the team chat, and my partner will send to you guys. Okay. Okay. Sorry. Okay. It's this one. Now, you can use the REST APIs or one of the SDKs for a specific programming language to use the language understanding model in a client app. We, I already sent you the documentation to do that. Okay. No matter what method is used, requests for prediction are sent to your language service with the following information: kind, parameters, and analysis input. The kind This tells us what kind of language feature you want. For instance, the kind is defined a conversation for understanding conversational language or entity recognition or recognizing entities. We have the parameters. This shows the values for different parameters that are sent in. Each feature has its own set of parameters. For example, project name, the deployment name are needed to understand conversational language. But only model version is needed to detect language and recognize entities. We have the analysis input also. This is where you tell the language service what documents or text string to look at. Okay? So the results of prediction are a hierarchy of information that your app needs to figure out. The results are JSON format when you use REST interface. SDKs show the results as a hierarchy of objects based on the JSON they are based on. The prediction results include the query utterances, or well, the top or this called most likely intent, other possible intents with their respective confidence score, and the entities that were found. Each entity has a category and, if necessary, a subcategory, as well as a confidence score. And the results might also show any other intent could be a match, as well as information about where each entity is in the utterance string. Example right here. We have the query, what's the time in Edinburgh? This is the query text. The highest scoring intent, or the top or most likely intent. The all possible intents, the entities recognized. In this case, the entities is Edinburgh. The category is location, the type, and the text detected in the entity. Well, so far, we've talked about how to use the language understanding service by using an Azure subscription prediction resource endpoint. The language understanding service can also be set up as a container. Just like many other cognitive services, it can run on local Docker host, on an Azure container instances, or an Azure Kubernetes services clusters. The steps you need to take to use a language understanding app in a container are shown in this diagram. First, you download and deploy the container image for the cognitive services API you want to use. This could be a local Docker server, an Azure container instance, or Azure Kubernetes service. Then the client application sends data to the endpoint provided by container for the service containerized and get the results, just like the wool from a cognitive services cloud resource in Azure. And this Periodically, metrics about how this service is used are sent to the cognitive services resource in Azure so that the service can be built. Okay, so, but well, let's take our module review. So, the first one, your app must interpret a command to book a flight to a specific city, such as a book a flight to Paris. How should you model the city element of the command? I'll give you a couple of seconds, guys. Okay, let's see. As an entity, remember the entity is the city is an entity to which the intent, in this case, a booking a flight, should be applied. Okay, next one. Your language model needs to detect an email when present in an utterance. What is the simplest way to extract that email? Okay, let's see. Well, remember, guys, when a language model needs to detect a common entity, we need to use the pre-built components to have the language services automatically the entity. Okay. The last one. Now, you want to get only the most likely intent for your natural language query. Which parameter should you use? I will give you a couple of seconds here. Okay. And remember, the prediction results top intent will contain the most likely intent for your query. Okay, guys, with this, we finish the module number 5, the creating language understanding solutions. Let's take a little break. You guys, I know it is boring hear me talking about these these services. So let's take a little break. I'm going to close this because I don't need it anymore. Now let's take a 5 minutes break. Okay, okay, guys, get some water, get some coffee, a beer, stretch your legs. See you in 5 minutes. Thank you, guys. Okay, guys, let's continue the last module of the day, building a question answering solution. Let's see our agenda. Our agenda is how to creating a knowledge base and how to publishing and using this knowledge base. So let's start with creating a knowledge base. The language services has a questioning answering feature that lets you create the knowledge base of questions and answers that can be queried using natural language input. The knowledge base can be posed to a REST endpoint, which client application usually bots and use. The knowledge base can be made from sources that exist, such as websites containing frequently asked questions, documentation, text files that are organized like brochures or user guides, or building pairs of chit-chat questions and answers that show how people usually talk to each other. A question answering knowledge base is a type of language model, which makes me wonder when to use question answering and when to use the language services ability to understand conversational language. Both of these features let you define a language model that can be queried by using natural language expressions, but there are some differences in the kinds of uses that are made for. In fact, the two services work well together. You can make a complete natural language solution by putting together models that understand conversational language and knowledge bases that know how to answer these questions. Okay, let's see how can we create a knowledge base. I don't know. I don't want to just read these points. So let me show you in the language portal. In a sec, I'm going to open again the portal. This language here. Right here. I'm going to create a language. It is this one, custom question read. Answering. Okay. Language for all projects or for just for this one. In this case, for all projects, I want to select English. The basic information, we can say Q&A, test, test purposes, and default answer. Okay, it is okay. Create answer. Okay, and got it. And we can manage our sources, URLs, files, chit-chat. In this case, for example, let's try chit-chat. In this case, let's see, I wanna, this is, chit-chat is like, it gives the bot like a personality. In this case, I want to have a friendly bot. Let's add in this resource. Let's wait a couple of seconds, guys. Okay, this can take a little, a few minutes. So instead of waiting, let me paste this right here. This is a frequently asked question from Microsoft Learn. We are going to use to create some new sources, new knowledge base in the Q&A. We are going to use the chit chat and on this URL, okay? In the meantime, let's continue with the slides. Okay. As you can see, to create a knowledge base, it is the simple, create the language services, then you need to create the project, and then you just need to use the chit chat or a page or a file. Let's see, let's give a couple of minutes to finish the knowledge base, and let's continue right here. Okay. Even though, uh, even though you can often make a good knowledge base out of separate questions and answers, you might need to ask follow-up questions to get more information from a user before giving a final answer. This is called multi-turn conversation. When there are more than two turns, you can enable multi-turn responses when importing question and answer from an existing web page or a document based on its structure. Or if you want, you can define follow-up questions and answers for existing question and answer pairs. For example, let's say the first question in a knowledge base for booking travel is, how do I cancel a reservation? The word reservation could mean either or a hotel or a flight. So a follow-up questions is needed to make this clear. The answer could say something like, the cancellation policy depends on the type of reservation. It could also include follow-up question with links to answers about how to cancel flights and hotels, right here, like this. So how can I cancel my reservation? Okay, and give us two options: hotel cancellations or flight cancellations. Okay. Now, when you set up this follow-up prop for a multi-turn conversation, we can link to an existing answer in the knowledge base or set up a new answer just for the follow-up question. You can also make it that so the linked answer is only shown when the original question starts a conversation with more than one turn. Okay. Let's see the next lesson, publishing and using knowledge base. But okay, let me see if my knowledge base is already completed. No, this can take a lot of time, guys. Don't worry, because that will add like, I don't know, 80 pair of question and answers or more. I can't remember right now how many questions are added with this chit chat. So let's continue, and then let's take a look to our knowledge base. Okay. Okay. Well, we can add the questions right here. For example, let's say mm, tell me about Cloud Week. Okay, let me finish this slide. Okay, and okay, it's example. Let's see the answer. Okay, Microsoft Cloud Week is a 5-day event that 5-day event and during flexible hours best fit into busy schedules. Okay, submit this one. Okay, got it. Okay, my source, sorry, I need to save these changes. Let's wait a few seconds. Okay, and okay. If you can see right now, I have a lot of, well, okay, 90 pairs are from this chit chat, and one, just one, it is about the Cloud Week. Let's take a look. The chit chat. Okay, I'm so bored of you, and so on. Okay, so let's try this. So, uh, let's see. Hi, let's wait. It is loading. Okay, hi. Let's inspect. This it is the confidence score. The answer it is, and this pair will come up from the Q&A chit chat friendly. Okay, so what happens in on board? Okay, okay, on board. Let's see. Answers thing I miss. Oh, let me see. That's a done. Yeah, let's see. It is okay. But let's say, uh, what is loud? Wait. If you say, if you can see right here, I just asked what is a cloud week. It is not the, the exact utterance right here, but I already get the answer. Okay, so we can use this Q&A to create a bot with frequently asked questions. How can we do that? Let's save these changes and let's see if we can use these frequently asked questions in order to create more questioning pairs. So manage source, I'm going to add another source URL. My URL is this one, and the name is Microsoft. See, go to detect at all, and this will take these the headers like the question and this as the answer. Okay, let's give a couple of minutes. Okay, adding source. It is that will that was quick. Okay, let's see. Okay, so we have a follow-up question. Let's test this. For example, let's clear this one and let's ask frequently asked. And okay, article, 10 minutes to read, 7 contributors. Okay, we need to edit this because we don't have this one, okay? But here's a list of the most common questions. And here we have the most common questions. If you can see, let me put this into separate, split my screen right here. Okay. For example, is advanced query understanding support? As you can see, it is the header. Can you search for files on premises? How do I make a Bing by default search engine? Okay. And if I don't know, select this. Where can I get info about Office 365, security, compliance, and privacy? Okay, details can be found on the Trust Center pages. Let's see is where can I find, here it is, my question and the answer. Let's do over again. For example, I don't want to ask everything and just um, Office 365, 365. Okay, and here we have. And that's all, guys. We already have our knowledge base. Now, you just need to deploy this knowledge base like this, real quick. This can take a couple of minutes. Once the our knowledge base is deployed, we can use a Postman to try it out, to use it in our app, or even we can use it to deploy a bot like this right here, create a bot. Okay, but this can take can take like 10 to 15 minutes. So let's say let's see this bot in the lab. Okay, guys. So let's continue. It is kind of easy. So now, publishing and using a knowledge base. We already we already saw how to publish the knowledge base. After you set up this knowledge base, you can train and test its natural language model before putting it out for an app or a bot to use. And this language studio let us put our knowledge to test by asking questions and looking at the answers that come back. We can look at the results and how the confident they are and what the other answers might be. Uh, when we are happy with how the knowledge base works, we can move it to the REST endpoint where the client's application can send the question and get answers like this, right here. Okay, prediction URL. We have this one, and this is a simple request. Okay, so let's continue. Okay, and this is example, right? We have the REST interface. We send the question. I want to book a hotel, and let's try it in Postman. Give me a sec. So I'm going to end this slide real quick, and let me. No, it is right here. So let me get the prediction URL. Okay, function, and I think it is in post. Yeah, we need post method, and I'm going to take this because I need the subscription key. Let me copy the subscription key. Authorization, headers. And I need to add this OCP, AP management subscription key. Subscription key. Name protection and body. Let's see. And my body needs to something like this question. Let's see if it works, guys. Okay, right here. So I just sent the my module. It is already published. As you can see, we have the name of the services, the knowledge base, the AP version, deployment name, production, and just need to add this subscription header, OCP AP management subscription key, our subscription key, And in the body, we need to send a JSON with the following question and the question. And we have the answers. Question, where can I get info about Office 365 security, compliance, and privacy? The answer, the confidence score, and the ID. And that's all. This is kind of easy, guys. We are almost done, guys. Don't worry. Okay. So let's continue. After making a knowledge base and test it, you can make work better by using active learning and defining synonyms. Active learning can help you to making changes so that it gets better and answering user questions correctly over the time. Active learning adds to the body of knowledge in two ways. Implicit feedback as requests come in. The service finds users submitting questions that have multiple matches in the knowledge base that have similar scores. And these are automatically grouped together as suggestions or different ways to say the possible answers. You can accept or reject these suggestions on the suggestion page of your language studio knowledge base. And we have the explicit feedback. By setting the top parameter in a client application, you can control how many possible question matches are returned for the user's input. Synonyms are helpful when a user's question could have more than one word that means the same thing. For instance, a customer of a travel agency might talk about reservations or a booking by saying that these are the same. The question answering service can find the right answer for each customer, no matter which term they use. Well, a question answering knowledge store can use by any kind of application, but it is most often used to help bots. A bot, remember, is a conversational application that lets people talk to each other using natural language through one or more channels, like email, like web chat, voice messaging, or a social media platform like Microsoft Teams. Question answering is often the first step in making bot, especially for conversational bots that answer questions from users. Because of this, Language of Studio lets you easily turn your knowledge base into a bot that runs in the Azure bot service. Let's take a look real quick. Let me close this. What is my knowledge base? Right here. Okay. So when we deploy the knowledge base, we just need to click right here on create a bot and follow the steps. Okay. Well, fill up the inputs. Let's see. Okay. We have the bot handle, the subscription. It is okay. Resource group, location, Central US. I'm going to set as East US. Pricing tier, it is standard. That is okay. Yeah, it is okay. Pretty standard. No, that's good for me. The app name, I'll leave it as default. We can select the SDK language because we can download this bot and after that we can edit the bot. I will send in Node.js. Well, C#, it is okay. Language resource key, app service plan and location. Let's see. I need to create a new one. This is the virtual machine where is the 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 bot hosted. And service plan bot. Location, once again, is the US. Let's click on OK. Application insights, I don't want it. Let's click on create. This can take 10 to 15 minutes to deploy. And after that, we need to wait up to 15, maybe 20 minutes in order to connect the knowledge base to the app service plan, to the application. So, but after that, it is kind of easy to deploy to the Teams, to Telegram, because you can deploy the bot, Azure bot to Telegram, to Teams, Direct Line, to Cortana, to Alexa, to Twilio. Well, we have a lot of platforms, a lot of channels here. So let's this deployment to work, and let's check the module review. Okay, guys. So let's see the first one. You want to create a knowledge base from an existing frequently asked question document. What should you do? I will give you a couple of seconds, guys, and let's see. And after that, we are going to see the answer. A couple of seconds here, guys. Okay, let's see the answer. Okay. Remember, you can create a knowledge base from an existing document or a web page. Okay, in this case, an existing pack document or using the web page. So the answer is B. Next one, how can you add multi-turn context for question and in an existing knowledge base? Couple of seconds here, guys. Okay, let's see the answer. To add to add a multi-tone context to a question, we need to define a follow-up prop question. Okay. The last one, how can you enable users to use your knowledge base through email? Okay, this question it is spelled. It is through email. Another couple of seconds here, guys. In this case, the answer is C. You can create the bot for our published knowledge base and configure the channel for email communication. Okay, we already finished this module. Let's take a look to the bot. And here we have. Let's see if it is already connected to the knowledge base. Hi. Okay. Okay, yeah. Cloudwick. Okay. And we already have our bot. How cool is that, guys? It is kind of easy, like 10 minutes, 15 minutes, I don't know. Uh, mm, let's take a look for see back. Okay, non-spawn, but frequently ask our, our following prompts. How are my search results protected? Okay, that's great. We already have our bot in Azure. We just need to deploy these bots to the channels. We can use to the web chat. This is uh, really easy because you just need to embed this code like this. Let's see, for example, like this. Use code. see if I can have. Oh my god. No. Sorry. This HTML sample like this. Okay. It is just a template. I'm going to save this right here. Test. And in the body, you just need to embed this code, this iframe. The secret right here, the secret keys. I'm going to copy this one. And that's all. Let's see. I think I can see this live server. Okay, no, I can do it, but let me open. Okay, here. And it's just like this. This is all obviously uh, just an example, right? This is the template HTML5, and I just embedded the the bot, but I can use it. Cloudweek, Office 365, Microsoft Learn. Okay, that's all, guys. We can make embedded this in our pages, in I don't know, a little button right here, using the framework you want, Bootstrap, or whatever you want. Okay. We have another channels like, uh, sorry, let's take a look at the channels like Alexa, direct line, email, Facebook, Teams, Line. In this case, if you, as you can see, we can use WhatsApp, we can use Telegram, but uh, you can use Twilio. You can deploy this to Twilio. Twilio and Twilio can deploy the bot to WhatsApp. So we have a lot of channels to this bot. Okay, pretty good, right, guys? It's kind of awesome. How can we do that in a couple of minutes? So, guys, that's all for today. I hope you enjoyed the session. And if you have any question, feel free to ask in the window. And if you don't have any question, we're going to see are going to see you in the labs environment, the labs Q&A. Okay, see you guys. Thank you.